A QR code, which stands for Quick Response Code, is much more than just a pattern of black and white squares. It is a type of two-dimensional barcode, meaning it stores information both horizontally and vertically. This is a big leap from traditional barcodes, which only store data in one direction. Because of this, QR codes can hold a lot more information, from website links and contact details to payment data and more. The best part? Your smartphone's camera can read and decode a QR code in just milliseconds, making it incredibly convenient for everyday use. Let us take a closer look at what makes up a QR code. At first glance, it might seem like a random arrangement of squares, but every part has a purpose. The three large squares in the corners are called position markers. These help your phone's scanner instantly recognize the QR code, no matter how it is oriented or tilted. Then there are smaller alignment squares, which keep the code readable even if it is stretched or printed on a curved surface. Timing patterns, which are alternating black and white lines, tell the scanner how big the grid is. The real magic happens in the data modules, those tiny dots that actually store your information in binary code. And finally, there is error correction, which is built-in redundancy that allows a QR code to still work even if up to 30% of it is damaged. All these elements work together to make QR codes fast, reliable, and incredibly robust. So, what exactly happens when you point your phone at a QR code? First, your camera captures the image. Next, the scanning software locates those position markers in the corners. It then reads the timing patterns to map out the grid. After that, it converts the tiny modules into binary code, which is just a series of zeros and ones. Finally, that binary data is translated into something you can use, like a website link or contact information. All of this happens in a fraction of a second, which is why QR codes feel so instant and responsive. They are literally engineered for quick response. One of the most fascinating features of QR codes is their error correction. QR codes use something called Reed-Solomon error correction. While the name sounds technical, the idea is simple. Extra data is added so the code can survive damage. This is why you can put a logo in the middle, print a QR code on a curved surface, or even scratch off a piece, and it will still scan. It is like having backup copies of your data built right into the design, making QR codes incredibly resilient. QR codes were first invented in Japan in the 1990s by Denso Wave to track car parts. Today, they are everywhere. Why did they become so popular? Versatility is key. They can store much more information than traditional barcodes. Accessibility is another reason. Any smartphone can scan them. They are fast, loading instantly with no need to type anything. Their resilience means they keep working even if damaged. And during the pandemic, contactless menus and payments made them mainstream. In short, QR codes are small, simple, and extremely effective. QR codes are not standing still. They are evolving into colorful, branded designs, dynamic QR codes that can change their destination, and even augmented reality-powered codes that blend the physical and digital worlds. The next time you scan a QR code, remember that you are interacting with a mini engineering marvel that is still growing and changing. So, the science behind QR codes is a blend of clever design, error correction, and lightning-fast decoding. That is why they are everywhere. They just work. If you found this breakdown helpful, hit like, subscribe for more tech explained simply, and comment with the most unusual place you have seen a QR code. Thanks for watching. Sometimes the smallest designs carry the biggest innovations.